The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Okay, it's 4 o'clock, so let's go ahead and get started. I'd like to welcome everybody to the Southeast Linuxfest. And before I do get started, I want to thank everybody, all the volunteers that have put in countless hours in order for us to have the Southeast Linuxfest and to give me an opportunity to talk to you about Object Pascal. So, show of hands, how many people here in the room have used Pascal in the past? Okay. How many people have used Object Pascal? Hey, very good. Okay, I've got a couple. Okay, yep, and we're going to discuss that too. So you can help field questions for me. Okay, who am I? I'm Brad Whitehead. I'm the Chief Scientist for Formularity. We're a secure electronic enrollment company. Prior to that, I was a partner with the global consulting firm of Accenture. I've been using Pascal, as you all have, since 1975, and I've been using Object Pascal since 1995. I had an opportunity to be one of the beta testers for Delphi, one of the two first commercial implementations of Object Pascal. Slides will be available on the company website, formularity.com. There won't be any need to go ahead and take notes or take pictures. If, in fact, you do want to go ahead and take pictures, this is my good side. Okay, Pascal was invented by Nicholas Wirth. He based it on Algol and Simula. Now, the interesting thing about that is that Simula also was the inspiration for C++. But despite that, the original Pascal was not object-oriented, it was strictly procedural. He developed it as a teaching language to be used in schools, but it became a very popular development language during the 1980s and 1990s. Probably the most, the most well-known version was Turbo Pascal from Borland. At that point, compilers for a PC cost about $200 to $300. Borland sold it for $39.95, and it was fast. At one point, it was doing 1 million lines, compiling 1 million lines per minute, which really doesn't seem all that fast until you realize that it was on a 4.7 megahertz processor. So, object orientation was added by Apple and Borland together. Apple went ahead and developed the Macintosh programming workbench, and Borland released Delphi. Now, the problem with Delphi is that it runs under Windows. This is a Linux conference. You can see it's a big problem if it only runs under Windows. So in 1997, the open source community went ahead and produced the aptly named Free Pascal compiler. It is, in fact, based off of the user look and feel of Delphi and essentially the same Object Pascal language, but it is a free and open source implementation. It has a GUI associated with it called Lazarus, and we'll go ahead and see Lazarus as we get further into this. At this point now, there are at least 8 implementations that I'm aware of Object Pascal compilers, both free and open source and proprietary closed source code. Okay, so why should you care about it? Okay, first of all, strong typing. Now, for a lot of people, they think, oh, that's a lot of extra work. I've got languages like Python where I don't have to do the typing. Typing's there for a good reason. It helps prevent memory errors, typing errors, conversion errors. Okay, and somebody else is now saying, but linters, we've got linters. Yeah, and do you run the linter every time? Or do you run the linter toward the end and suddenly have all those mistakes you have to go back and fix? With the compiler going ahead and enforcing all the type conversion checking and whatnot, it runs a lot more smoothly and you're more guaranteed to get error-free code. Pascal uses both an interface section and a implementation section. Now, this is somewhat equivalent to the export statement in something like JavaScript. Anything that's in the interface section is available to other programs. One of the other advantages, too, is that you can go ahead and write and publish the interface section. Other developers can now develop against your code while you're still writing the implementation. And finally, it's very good for separating the what from the how. What is the interface? How is your implementation of that interface? And you can change it at any time so long as you keep the interface the same. Okay, one of the real hot topics, and I've heard it several times here today, is memory safety and the Rust language. Okay, memory management in C and C++, it's kind of like juggling razor blades. It's great as everything works out fine, but slightest mishap, and suddenly you've got a use after free error, or you've got a memory leak involved. Object Pascal goes ahead and uses reference counting and null pointer detection right in the compiler itself to go ahead and prevent those types of memory errors. We'll also talk about pointers later on too, but basically Object Pascal is memory safe, and it's a syntax that you're familiar with. You don't have to learn the separate syntax and operating model of Rust. Compiles to machine code. And not a bytecode virtual machine, but actual machine code for the platform in which you're operating on, which means it's extremely fast. You've got C type of execution speeds. Any Python programmers in the room here? Okay. You'll notice a lot of similarities in the syntax between Object Pascal and Python, and that's to your advantage. If you're an accomplished Python programmer now, you can very easily pick up Object Pascal, and you pick up two things. You pick up, you pick up the strong typing and some of the other things I've talked about, but you pick up tremendous speed, and you also pick up true multi-threading. There's no global interpreter lock in Object Pascal. Whoops. I think I pressed the wrong button. I apologize. Let's see if I can get it restarted here. Close enough.
Run VS Code and Python, it hits the file every time you say it. So it does run all the time.
That's good. No, I wasn't aware of that. Thank you very much, TC. Okay, Python, or I'm sorry, not Python. Object Pascal is a system language. As I said, it was used to write the original Macintosh operating system. It is used, and it can be used, and it is used to write operating system code. If you can't do it in Pascal, it has an integrated assembler. You can drop down into the assembler. Variables pass transparently between Pascal and the assembler, making life easier for yourself. Okay, here are the available Pascal compilers that I'm familiar with. As I said, you've got a mixture of both free and open source software and some commercial proprietary software. Let me go ahead and say a few words about Delphi, or Delphi, the third bullet point down there. It is commercial, it is closed source. However, they go ahead and give you a community edition that is full-featured. There are no restrictions on it. It's time unrestricted, so you can use it for as long as you want. You can even go ahead and sell software that you've generated with the community edition. All they ask is that when you hit sales of $5,000 per year, that you go ahead and buy the compiler, which seems fairly reasonable. But the reason it's important is because while the free Pascal compiler can go ahead and cross-compile to Android and to iOS, it's not as clean as some of the other cross-compilations. And I'll show you a couple cross-compilations during the demo. But Delphi has worked out the cross-compilation to Android and iOS very smoothly. And again, I'm going to go ahead and demonstrate, time permitting, I'm going to demonstrate on Android, and we're going to go ahead and use Delphi for that. There are even some Open Pascal interpreters. The first four here on the list are online development environments. Basically, you write your code through the browser. The last is a scripting version of Object Pascal. It's designed to be embedded within your program so that if you need to give scripting capability to your end user, you don't have to go to something like Lua or some other scripting language. You can go ahead and give them a scripting language for which you're familiar because that's what you use to write the code. Okay, this is a gee whiz slide. Everybody say, gee whiz, look at all the platforms that you can compile for. And here's the second gee whiz slide. Look at all the operating systems that OpenPascal can go ahead and generate code for. Most importantly, I didn't realize until I put this list together that the free Pascal compiler can generate code for the Nintendo Switch. My daughter's a big Switch fan, so next project, once I get home after this, is to learn how to write a Nintendo game so I can write her one in Object Pascal. And, you know, hey. Okay. Object Pascal, very much like the original Pascal, has a very rich flow control. There's the if-then. There are cases. One of the nice things about cases is you don't fall through cases like you do in some other languages. Each case stands alone, and when it's completed that case, then it goes down to the next line of executable code below your case. There's also an else case, and that'll catch anything that you didn't have a specific case for. It does fixed iterative looping. It does looping before the loop. Before the fact, it does comparison before the fact, and it does comparison after the fact. All of the data objects in Object Pascal are iterable, which means you can go ahead and use for-in statements and iterate through the data collection. And it uses exceptions for error handling, and pun intended, finally, there is a finally clause that will guarantee to execute, and that's where you can go ahead and close your database or your file or whatever you need to do while your program's crashing. Okay, it's got the traditional data structure, or data types that we're used to, various different types of strings, various different types of numerics, and Boolean, but it also has quite a number of data collection objects, static and dynamic arrays, and we'll talk a little bit more about those, records, sets, dictionaries, lists, class lists, pointers, variants, enumerations and subranges, and objects and classes. And again, you know, Python is very rich in various different data structures, but I think that we've got everything covered here as well under Object Pascal. Okay. The class is the heart of Object Pascal, so let's go ahead and spend a few minutes talking about that. In this particular example, we have the T-Wall class. By the way, everybody planning on attending the beer social tonight? Okay, so you'll see the theme is kind of beer related here. We have a wall class, and the wall class is inherited from the T-object. The T-object is your most basic object type. It comes with the compiler. You just go ahead and instantiate things from, or inherit things from T-object. Now, in the religious war of multi-inheritance versus single inheritance, Object Pascal comes down on the side of single inheritance. But that's really not a problem because just like with Java, if you need multiple inheritance, you have interfaces. So you can go ahead and use interfaces. There are 3 different types of data access controls within a class. There's the private, as you might expect. Only the object itself can go ahead and touch these variables. They're invisible to the rest of your program. We have T-beers here, which is an array of T-beer. It's an array of beer. Arrays in Object Pascal can go ahead and hold other objects. They can hold other data collections. They can have an array of dictionaries. You can have an array of arrays. In this case, we have an array of objects. Next one down, this number of beers is an integer. That's going to keep track of how many beers we've still got left on the wall. Okay, we have the public data accessor, which, as you might expect, again, allows any part of your program to go ahead and access anything that's below the public here. So we have a function called tell count, and that's going to return an integer to us. It's going to tell us how many beers are still on the wall. And we have a procedure, which is remove beer, and we tell it how many beers we want to remove from the wall. Now, there's really virtually no difference between a function and a procedure, other than a function returns a value, a procedure doesn't. So I'm going to just refer to them as methods for the most part as we go forward. And then there's the constructor. Now, your constructor basically goes ahead and sets up all the initial conditions when you convert from a class into an object. So if you need to set some variables, if you need to do some checking, anything like that, that's all handled through the constructor. You have protected class. Now that means that things like the private and whatnot can be accessed by children classes. So if you derive something from class T wall, maybe like T brick wall, it would have the ability to go ahead and look at the F beers and the F number of beers. It's got protected status. And then finally, we have properties. Now, properties is just syntactic sugar. It's a way of making a method look like it were a variable. And so why would you go ahead and do something like that? Okay, so we have F beers up there. We don't want to just give out F beers and tell everybody what that number is. We may have to do some checking to be sure whether the date of those beers are still, fresh or not. I don't know what the case may be, but you want to be able to run a procedure. When somebody asks to see how many beers there are, you want to be able to run a procedure and return the information to them as if they had read it directly. Same thing with a write. You may not want people writing directly into your variables. You may want to go ahead and do some checks before you allow that information to go into the variable. So reads and writes are controlled under the property here. And you can see here, a read will read the number of beers directly, and the write will go ahead and go through tell count first before it puts the information into number of beers. Got to keep up with my slides. Okay, I talked about interfaces. Object Pascal supports both Microsoft's COM interface as well as the older Corba interface. You can have direct calls from Pascal into C and C++ libraries. Vice versa, C and C++ programs can call into Pascal libraries. So you have complete interchangeability. You do have to turn off the name mangling in C++, but then you have to do that for interoperability between C++ and C itself. We have exceptions for error handling, including that finally that I mentioned. Most of the methods in Object Pascal are concrete, which means that they execute directly. But if you need runtime polymorphism, you can go ahead and create virtual methods, and they'll be dispatched through the virtual method table. It's slower, but it gives you more flexibility. Generics, I'm not a big fan of generics, but if you need to go ahead and build data types from templates, Object Pascal has that feature capability for you if you've got the use case for it. Nested and anonymous functions. You can go ahead and nest functions to any depth that you want to. Embedded functions can see the variables of the function above them. You can also create functions that have no name, anonymous functions. Now that's important in a language like JavaScript, but I'm not so sure that's important in Object Pascal. But if you've got the use case, it's got the capability. Pointers, I mentioned pointers. Pointers can point to memory and they can point to procedures. So that's how you do your callbacks. You just go ahead and give a pointer to where you want to execute the code for your callback. The only thing it doesn't allow you to do is it doesn't allow you to do pointer arithmetic, because that's just asking for memory errors as you go ahead and read off the end of an array. Class helpers are kind of interesting. and I think a couple of other languages have them as well. Basically, you can extend an existing class without having the source code for that class. So if you need to add some additional functions onto a class that you didn't write, and you don't have the ability to go in and change the source code, or it's a library and you don't want to go in and change the source code, you can add the helper to it as if it were the original method or original variables. And Object Pascal is case insensitive. And again, there are some people out there that are saying, well, that's a drawback, not an advantage. And it's not a bug, it's a feature. No, actually, I strive to write error-free code. I think we all do. And the difference in a variable or a procedure is just the shift key, I think, is asking for an error to occur. So I personally like the object of the case insensitivity. Okay, learning it. Excellent resource, the Modern Object Pascal Introduction for Programmers, and there's the URL for it. It is an online book. It is designed for programmers, so it's not going to go ahead and tell you what a variable is or what a loop is. It's going to tell you how to write variables and how to write loops within Object Pascal. There's also the free Pascal wiki, which has a number of documents, as well as pages, just about any subject that you can think of relative to any question you might have relative to Object Pascal. There's probably a page in the wiki that covers it. And finally, Marcus Fernstrom has gone ahead and done a series of YouTube videos on Object Pascal, which is great for going ahead and seeing how the language actually works. He's very good at explaining things. Most of his stuff is oriented around web use of Object Pascal and JSON objects. How are we doing on time? Okay. I want to save time for the demo. Speaking of the demo, okay, everybody normally goes ahead and does hello world for their demo. And all that does is prove that the language has an I/O capability. It really doesn't exercise anything. And even with Pascal, you could go ahead and write 99 bottles of beer on the wall in about 6 statements if you just want to go ahead and do it procedurally with a loop and a couple of print statements. But hey, this is Object Pascal. I wanted to go ahead and demonstrate to you all the use of objects. So I've got a wall object, I've got a beer object, and I've got a people object. And I'm going to go ahead and set the 3 playing together. And then, to make life more interesting, you know, it's no fun just seeing the song be printed out. I went ahead and incorporated a text-to-speech synthesizer so that we can actually hear it sing 99 bottles of beer on a wall. Time permitting and the demo gods permitting, I will go ahead and show this running on Linux, Windows, Mac, and Android, all the very same code base. So, let's see. Okay, iChart time. No, I wanted to go ahead and show live code, but as you can see, live code's going to be too small to actually, be visible. So this is the Lazarus IDE, and I'll very quickly just kind of go over it, and then we'll go again to some larger text. So over here in the corner, this is a list of the particular objects that I dragged and dropped onto the form. The form is your graphical user interface. So I grabbed some buttons and I dragged those on. I dragged a progress bar on, a couple of other things. We'll go over those. And then when I click on one of those widgets, in the lower pane, I'm able to go ahead and set attributes about that widget. Its color, its name, its contents, anchors, size, location, anything I want to go ahead and change numerically or a specific concrete change in attribute. Okay, this is where the text editor is. It's not quite as user-friendly as VS Code or as comprehensive as VS Code, but it does in fact have IntelliSense, so it will go ahead and suggest options to you, and it'll show you all the method signatures as you're going ahead and calling a method. That's also where you can go ahead and click and create your breakpoints for your debugger. The window down here is for messages. As the compilation and the build go on, messages show up here. If you should happen to have errors, I've been told that they'll go ahead and show up here in this script down at the bottom and help you then go ahead and figure out what you did wrong. But what we're going to wait for today will just be the green successful message bar. And finally, over here is the palette. And these are all the different things that you can drag and drop onto the form. So these are buttons, labels, text fields, progress bars, web servers, you name it. There's something there that you can go ahead and drag onto the form and then go ahead and set its attributes. And then finally, up at the very top are the usual editing and search features, as well as setting project options. And again, I'm going to go show that in a little bit further. Okay, this is the graphical user interface that I've been talking about. This is the form. I've dragged and dropped 3 buttons out there, and I've changed their captions. So one button is load up the wall. One button is start passing them around. And the third button is to stop, because we really don't want to go through all 99 bottles of beer. This over here is a progress bar, and we're all used to the progress bar showing us how well the download's going or whatever that may be. In this particular case, it's vertical, it's wide, and as I put beers on the wall, it'll start filling up. As we take beers off the wall, it'll start going down. Now, when I first wrote the program and I said, okay, 99 bottles of beer on the wall, the progress meter just went green. So that really wasn't very impressive. So I went ahead and I put a wait state in there. So now there's a little bit of animation you'll see as it goes up. And that's not the virtue of the speed of the language. That's the wait state that I put in there. You can't see it here, but this is a label. And this is where it's going to go ahead and print out the verses of the song as it sings them. And over here, this little widget right here, that's a T-process widget. That's where I go ahead and tell it what external process I want to run. In this particular case, it's the voice synthesizer. And then finally, we've got the caption for our window itself. Okay, here are the 4 classes that are involved. We'll dive into each one of them. The first class is the form class itself. As you can see, it has 3 buttons, a label, 3 buttons, a label, a progress bar, that process widget. It has 4 procedures altogether. The first 3 having to do with dispatching once you go ahead and press one of the buttons. And the last one is a pseudo constructor for the progress bar. When I was debugging the program, I really didn't want to have to sit through 99 bottles of beer just to be sure that everything was working right at the very end. So I set it up so that there's one global constant, and I can go ahead and fill in how many bottles of beer I want. But the progress bar, the graphical progress bar, has to be set each time as to whether it's 100 bottles of beer or whether it's 3 bottles of beer, and so it'll increment correctly. So that's what that particular process there at the bottom does. Okay, our beer class doesn't do a lot. Doesn't have any data, doesn't have any methods other than the mandatory constructor. But we needed a beer object, so there's a beer object. Okay, we have the wall class. It has an array of beers. Now notice there's no size on that array. Again, because we could have 99, or we could have 3, or we could have any number. So one of the things we go ahead, this is called a dynamic array. One of the things we'll go ahead and do is, in this particular case, I'm going to tell it we have 99 beers, and it'll go ahead and allocate the space. But it also can be done incrementally. I could do it 1 beer at a time, and it'll go ahead and copy over the array each time, making the array one increment larger. We have our number of beers, which is an integer. We have the function tell count, which I'd mentioned earlier. It goes ahead and returns an integer telling you how many beers are still on the wall. Now, what it's also going to go ahead and do, that's where I put in the lyrics for the song. So not only is it going to tell you the count, but it's also going to print out the lyrics for the song. And then there's the create constructor here. And that's where we tell it how many bottles we want to go ahead and put on the wall. We have the person class. The person class doesn't have any data, but it does have three functions or three methods. The first one is load the wall, self-explanatory. Next one is pass it around, again, self-explanatory. And the third one is the constructor, and there's nothing really to go ahead and construct with the person, so again, it's an empty constructor. Okay, what we've been talking about so far are classes. Classes are like templates. You convert them into objects. You use them to construct objects. And objects are put under variables. So here are 4 variables that represent what I'm going to go ahead and put into that variable. So in FRM wall, I'm going to go ahead and I'm going to instantiate a type form wall. Person, I'm going to instantiate a class of tPerson, and so on and so forth. Some of the times people, and I'd be the first to go ahead and tell you when I'm doing a lecture like this, is I tend to mix up classes and objects. Classes are the templates, objects are the actual creations. You can have any number of objects of the same type of template. Okay, just to give you a look at what the code kind of looks like, this is the pass it around procedure, and as you can see, we've got a while loop going on here, and what happens is every time we take down one of the beers, we set that array location to null. Null is a recognized designation within the language. So that I can't accidentally go ahead and use that location again unless I specifically put something in that location. Do a couple form updates so that our screen will actually go ahead and change. Again, in debugging, I forgot to do the screen updates. So the whole thing ran and all it printed out was 0 bottles of beer on the wall. So we need to go ahead and update the form as we go along. Okay, let's see. Let me go ahead and get into the demo itself. Okay. Okay, mirror the two, apply. Hopefully we're going to see my screen. Yes. Okay, we're going to keep those changes. Put this away. Put away our slides. Let's go ahead and fire up the compiler. Okay, there's the IDE that we went over earlier. And so let me go ahead and go to recent projects, and I will open up our self project, self 2025. And here is the code. Whoops. What happened? That's not our code. Open recent, self. No. Okay. Okay, demo gods may not be with me today. Let's see. Close all. Open. What's that? PRJ file, you're correct, yeah. Let's see if this does it. Open project. Save changes to project number 1, no. Thank you very much. That did it. Now, I told you I was going to call on you to help me with the questions. Okay, so this is the...
I haven't done it as much with Linux, so there could be some variance over the ages.
Yeah, but now you know it's available for Linux, so you can go ahead and start using it. It's an yeah. This is the IDE that we went over right here, and lurking behind it is our user interface. Here are those buttons that I created. And there's another button down there. Let me drag the window large enough. Yeah, there's the other button there. There's the progress bar. You can't see it, but the label there. So let's go ahead and get things started. Run without debugging, so I don't have to worry about pulling in the debugger. Looks like we got 2 copies running. So let's see. No. Quit. Wait. Let's see. Cancel. Am I closing out the right one? Yeah. I apologize for this. Okay. And let me go ahead and check. Project options, targets. Okay. Right now it's set for Windows 64. So let's go ahead and set it for Linux, since this is a Linux laptop. Okay, it's going to go ahead and compile for Linux, and it's going to compile for a 64-bit chip. Hit the OK button. Now let's go ahead and run without debugging. Hey, we know it'll build the Windows version now too, because we got the green message when we built the Windows version. But here we go. Here's our program running now. So let's go ahead and load up the wall with beers. Here's my cute little animation. Okay, let's start passing them around. Now, it may take a moment for the voice synthesizer to kick in.
99 bottles of beer on the wall, 99 bottles of beer. Take one down and pass it around. 98 bottles of beer on the wall. 98 bottles of beer on the wall, 98 bottles of beer. Take one down and pass it around. 97 bottles of beer on the wall.
Okay, you got the idea. Okay, so let me show you how easy it is to go ahead and compile for Windows. We go down here to targets, and here are a list of, this is kind of the gee whiz slide. These are all the different operating systems that it supports. And we will go down to Win64. And again, these are all the different processors that it goes ahead and supports. It's becoming obviously more important, ARM support for Windows. But we're going to stick with our x64 since this is an older laptop. Okay, now we'll go ahead and compile. And we'll build. And we're getting green bars for both of those. But obviously, we can't run it because this is a Linux laptop. So, just like one of those cooking shows, I happen to have a Windows virtual machine just hanging around. So let's go down to our code. This is our code right here. You can see Project 1, which is the Linux version. We obviously can't run that under Windows, but just beneath it is project1.exe, and I'm sure everybody's familiar with the .exe extension, that being a Windows executable. So let's go ahead and double-click on that. And here's our program running under Windows now. Very same code. We didn't make any changes. We just did one compilation after the other. We load up the wall. Oh, it's a different shade of green. And here's that weight.
99 bottles of beer on the wall. 99 bottles of beer. Take one down and pass it around. 98 bottles of beer on the wall. 97 bottles of beer on the wall. 97 bottles of beer. Take one down and pass it around. 96 bottles of beer on the wall. 96 bottles of beer on the wall. 96 bottles of beer.
Stop.
Take one down and pass it around.
Stop.
95 bottles of beer on the wall.
There we go. Okay.
Are they statically compiled binaries or are they using DLLs?
Statically compiled. Yes. Yeah. You can write DLLs if you want to, but the standard model is statically linked.
Yeah, the way I used to link all of it around, I'd write my DLLs in C
Okay.
and turn around and call them through Pascal. Is the way I used to do it.
Okay, then that's perfectly good. I mean, that's kind of the way to do it, type of a thing. Especially if you've got C libraries that already go ahead and do what you want, just go ahead and reuse them. So, okay, I talked about Delphi, and again, I just happen to have Delphi hanging around in my Windows virtual machine. And it has to be the Windows virtual machine because Delphi only runs under Windows, even though it will compile programs for Linux, Windows, Mac, Android, and iOS. It still only runs under Windows. I don't know why they don't just go ahead and eat their own dog food and compile it, but they don't. Okay.
Against Android, or will it automatically build the manifest?
Automatically builds the manifest. Yep. So let's see here. Now it's a lot easier. This is where I was talking about the ease of doing cross compilation with Delphi. I just go ahead and click here. Now I've got a older Amazon Fire tablet up here. It's only got a 32-bit ARM processor in it, so we're going to go ahead and go for 32 bits. And we will say run without debugging. Now, if everything is set properly, we're going to go ahead and see it compile, link, deploy, all the different things that are involved in going ahead and putting together a Android program. And then it's actually going to go ahead and run on the tablet here. Now, I was set up to go ahead and be able to display the tablet through the screen, but things just didn't work out relative to hardware here at Self. The tech team here has been absolutely fantastic in helping me out today with a couple of other problems I've got. But in this particular case, all I'm going to be able to do is one, hold up the tablet. And also tell you, too, I couldn't get the voice synthesizer to work under Android. What's going to happen is every time it prints out one of the lyrics, an error message is going to come up. The error message is down on the Java side. I don't know if you all are familiar with how Android works, but all the Android programming is in Java. All the APIs for all the functions of the tablet or the phone are all in Java. So there's a Java native interface, and Pascal calls from the Java calls through the Java native interface to the Java API. And the error message is indicating that it's on the Java side, and I just did not have enough time to go through and do the debugging on that.
Think that was maybe the Fire version of Android causing you grief?
I hadn't thought about it, but you're right. I mean, first of all, this is an old one, So
It's kind of Android.
it's and like you say, yes, the Fire operating system is kind of Android, but it's not exactly Android. So that, in fact, may be the problem. I'll go ahead and try it on the phone next. I'm not here, but okay. So we go ahead and we load up the wall, and it fills up our progress bar, and this is a progress bar under Android, and I know you all can't see it, and I apologize. And then when I say pass it around, it comes up with the first verse, and then goes ahead and gives me the error message. And so I tell it, okay on the error message, and I say pass it around and gives me the next verse and goes on and so forth. But what you just saw was you saw the very same code that was running under Linux and Windows, now running under Android. And if anybody's done Android development in here, you know that life generally is not that simple. So this is, again, one of the features of Object Pascal. Okay, we're right on time. So at this point, let me go ahead and ask if there are any questions. No, I didn't do a good job explaining if you don't have questions.
I was just going to ask, as far as like language features, what about like closures, or because you mentioned being able to do like callbacks by like passing in a pointer?
Right,
But
right.
what about like closures or?
It doesn't have the concept of a closure.
Okay.
Yeah.
Can I address that? I mean, you say that you could have a function that has another function in it, right?
Oh, yes, you can.
So you.
Oh, okay.
So I just wanted to clarify.
I appreciate that clarification. Thank you. So, yes, we do have closures. It's not something that I've gone ahead and used, so I'm not all that familiar with it. I'm familiar with closures from JavaScript, but I hadn't made the equation to Object Pascal. Thank you. Okay, well, we'll go with it. Other questions? Okay, I want to thank everybody, and I'll see you all at the beer social tonight, and we'll do 99 bottles of beer on the wall.